Hello IP students. Today our topic is Python NumPy array. This is Python NumPy array part 8. In this lecture we are going to discuss about some mathematical functions used in Python NumPy, and some of them are trigonometric functions. These are sine, cos, tan, etc. So let us take them one by one. There is a program which implement trigonometric functions in Python NumPy. First line is import NumPy as NP. Import NumPy as NP. Import is a keyword, NumPy is the name of library, and NP is the alternative name of Python library NumPy. So whenever we want to use NumPy, just write NP in place of NumPy, and then after dot sign, and after that name of function belongs to that library. So second line, AP is equal to NP dot array. Basically in this line there is a creation of an array, and then after sign of different angles will be taken, and there is a comment says that it converts to radians by multiplying with pi by 180. So first thing which we have to be done is that convert degree into radian. So to convert degree into radian, multiply it degree into value in degree into pi divided by 180, and pi is defined in NumPy library, so just use np dot pi. So there is a print statement, print np dot sign a multiplied by np dot pi divided by 180. Next line there is slash n. In similar manner, cos and tan functions perform also, and after the execution of that programs, different value regarding to sine, cos and tan tangent of a given angles will be printed. Next is numpy around. Numpy around. Now this is a function that returns the value rounded to the desired precision. And the function take the following argument. Basically it takes the two parameters, numpy dot around a dot decimal. So there are two parameters, a and decimal, where a is the input data. It may be a number or maybe an array, and decimals, the number of decimal to round to default is 0. So it is very important point. The value of decimal is default to 0. If negative, the integer is rounded to the position to the left of the decimal place or point. So it is very important. If negative, the integer is rounded to position to the left of the decimal point. Now it is a small program in which second line, first line is import numpy as np. Numpy is a library which belongs all basic operations related to arithmetic calculation. In second line there is a creation of an array. In line number 3rd, original array, there is a print statement, and in 4th line array will be printed. Line number 6 slash n means cursor goes to next line. Line number 7, after rounding it will print it as it is because print statement is there. And then after, the important thing is print np dot around a, and then np dot print np dot around a decimal is equal to 1, and then last line np dot around a dot decimal is equal to -1. So what happens in this line around a? So by default, as we know that decimal is equal to 0. So if it is not given, decimal is equal to 0. And second, around function contain decimal is equal to 1 as a parameter, and in line number 3rd, decimal is equal to -1. Line number 3rd belongs to around statement here. So line a is equal to decimal is equal to -1. So first value that will be printed around a with decimal is equal to 0 because 0 is by default, and then around a decimal is equal to 1, and last line around a is equal to decimal is equal to -1. Now this is the output of the following program. The given array is 1, 5.55, 123, 0.567, and then 25.532. So these are the elements of an array. After rounding, in first case, remember default value is 0. So 1 point remains same, 5.5 becomes 6. 123 is converted to 123, again there is no change. 0.567 is converted to 1, and 25.532 converted to 6 after rounding off, because default is 0. So default is 0 in this case. In array second, default, when default is equal to 1, 1 remains same. 5.55 converts to 5.6, because there is only round up when value is equal to 5 or greater than equal to 5. The only difference is that the position, whether it is default 0, default 1, or default -1. In second case it is default 1, so after decimal place we take first digit. So 5.55 becomes 5.6 minus 123 point. There is no digit after decimal, so it remains same. And then 0.567 becomes 0.6, and 25.532. Now here 32 is less than 0.5. 0.032 is less than 0.05, so it will become 25.5. Now last line, when default is equal to -1, so it is just opposite to that of +1. So instead of rounding off after decimal, it converts the value before decimal. So 1 becomes 0, because 1 is less than 5, and second 5.55 becomes 10, because 5 is greater than 5 is greater than 5 is greater than or equal to 5. 123 becomes 120. 3 is less than 5. 0.567, this is smaller number, less than 1, so it will become then it will become 0. 25.532, and it is converted to 30, because 25 is in 25 5 is greater than or equal to 5, so the final answer is 30. That is the use of around function. Always remember that in around function default is 0 if not mentioned decimal value. Next is NumPy floor. So NumPy floor, this function returns the largest integer not greater than the input parameter. This is very important point, and it is the definition of floor function. The function returns the largest integer not greater than the input parameter, and we can remember it as I is less than equal to x, where x is represent the scalar value. So the floor of the scalar x is the largest integer I, such that I is less than equal to x. And the most important thing is the in Python, flooring always is rounded away from 0, is always rounded away from 0. So there is a small program marked with the red pen. First line, import numpy as np. Second line, a is equal to np dot array. There are some elements belongs to that array. Next line, there is a print statement. Next line, line number 4, there will be an array which print a. Next line, print /n. Cursor goes to next line, then the modify array will be printed as it is as given, and next print np dot floor. So it is very important point, np dot floor. Now the floor operation perform the functionality on each and every element of an array, and array consists 5 elements here. So this is the array, given array, and its element are -1.7, 1.5, -0.2, 0.6, and 10. So after passing these values as an argument in flow functions, -1.7 becomes -2. Remember the definition. This function returns the largest integer not greater than the input parameter. So -1.7 becomes -2, 1.5 becomes 1, -0.2 becomes -1, 0.6 becomes 0 and 10 is 10 remains same. This is a NumPy floor function. Next is NumPy ceil. So this NumPy ceil function is basically just opposite to that of floor functions. It's just opposite to that of floor function. So here condition is I is greater than or equal to x. Now let us check again the output. Minus 1.7 becomes minus 1. So just opposite to that of floor function. 1.5 becomes 2. Minus 0.2 becomes minus 1. Um, Minus 0.2 becomes minus 0. Sorry, minus 0.2 becomes minus 0. 0.6 becomes 1 and 10 remains unchanged. Next is some arithmetic operations. To perform some arithmetic operation, add, subtract, multiply or divide, these are the basic arithmetic operation, and the function used for this purpose are add function, subtract function, multiply function and divide function. So let us take them one by one. There is small program. In this program, first of all, an array will be printed, and then second array contain element 10 10 10. First array contain 9 elements and it is a two-dimensional array, or it is a 3 by 3 array. In next line there is a addition of number of elements of two arrays using add function, then subtraction using subtract function, then multiplication using multiply function, and then divide using divide function. Note the important point is that the element of an array or the size of the or the shape of the array must be of same. If you use two array, so that is the output. This is the first array having size 3 by 3 and second array having size 1 by 3. So at least number of columns should be same, or they may be of same size. Only then the operation will perform, otherwise no operation will be performed. So first so it is a very important point that whenever you want to perform addition, subtraction, multiplication, division using array, then if you take two arrays, the size of the second array, the shape of the second array is same as that of first one, or the column regarding to the second array must be same as that of first array. So here first array contain 3 columns and second array contains 3 elements. So after addition of two arrays, actually second elements of second array add to each and every row of first array. So when we perform addition, and if contain the size 3 by 3, if second array have size 3 by 3, then each element add to the respective position as that of the first one. But since size is 1 by 3, so the elements are added to each row. So after addition of two array, elements are 10 11 12, because 0 plus 10 is equal to 10, 1 plus 10 is equal to 11, and 2 plus 12 is 10, 2 plus 10 is equal to 12. Same for line number 2. 3 plus 10 is equal to 13, 4 plus 10 is equal to 14, 5 plus 10 is equal to 15, and up to so on. In similar manner, subtraction can also take place. Similarly, multiply can take place, and similarly divide of two arrays can take place. Next is the reciprocal function. This function returns the reciprocal of the argument element wise. For example, with absolute value larger than 1, the result is always 0 because of the way in which Python handles integer division. For integer 0, an overflow warning is issued. So try not to use 0 when use just divide operation, divide function or reciprocal functions. This is a program which perform reciprocal of different elements related to array. So there is an array and it contains element 0.25, 1.33, 1, 10 and 100. Line number 2. And we want to use reciprocal of these elements, just write np dot reciprocal and then pass array as an argument. And this is done in line number 7. Print np dot reciprocal a. And next, line number 9, b is equal to np dot array 100. So there is only a single element 100 and its data type is explicitly mentioned and its data type is int. And then reciprocal of element b can also be takes place, and this is done in line number last line. This is done in last line. Now this is the output. Elements of array are 0 0.25, 1.33, 1, 10 and 100. After taking reciprocal, reciprocal of 0.25 is 4, 1.33 is 0.755, 1 is 1, 10 is 0.1 and 100 is 0.01. And for second array, since there is only one element of integer type, it is 100, so its reciprocal is 1 divided by 100, approx 0.001. So finally it is 0. Now numpy power, as the name suggests, it will take the power of a given element. So this function treats element in the first input array as a base and return its raise to the power of the corresponding element in the second input array. So this is a small program pointed my red pen. Import numpy as np. A is equal to np dot array 10, 100, 1000. Print our array will be printed. So the important point, whenever we want to use power function, just write name of library, which is np in this case. Np belongs to numpy, of course. Dot operator is there, and then power function, and then pass as a pass two argument. First one is value or an array, and second is power. If you pass a array as an argument, then and power goes to each and every element of an array. So this is the output. Array is 10, 100 and 1000. Power is 2, so 10 power 2 equal to 100. 100 will be printed. 100 power 2 becomes 10,000 and up to so on. So this is the way the power function used. Second array contain element 1, 2, 3, and here apply power functions again. Now here power a b. So the important change in this part is that a is an array, also b is also an array. So a is an array and b is also an array. So array 1 contain 3 elements and array b contain again 3 elements. So there is a matching of 1 by 1. So it means 10 power 1, 100 power 2 and 10,000 power 3. This will be printed. This is the final output. Next, numpy mode function. This function returns the remainder of the division of the corresponding element in the input array. The function numpy.remainder also produces the same result. So basically there are two functions, mode function and remainder function, which perform almost the same functionality. You can use numpy mode or you can also use numpy remainder. There is no difference among them, between them. So first line is import numpy as np array 10, 20, 30, np array 357. First array, second array, apply mode function. You can use two values or you can also use two arrays. So here two arrays are passed as an argument or as a parameter in mode function as well as in remainder function. Because both have same functionality, so the answer will be the same. That is the final answer. That is an array. First array 10, 20, 30. Second array contain element 357. So there is 1 by 1 matching. So when we divide 10 by 3, then the remainder is 1. So 1 is the final answer. Similarly, when 20 is divided by 5, the answer remainder is 0. So 0 will be the answer. And when 30 is divided by 7, remainder is 2. So 2 will be the answer. So final answer after mod function is 102 in the form of an array. And because the functionality is same as that of mode and remainder function, so answer will not change. So answer will again 102 when we use remainder function. There are some other functions which are related to complex number, and these functions are numpy.real function. It basically returns the real part of the complex data type argument. Whenever you find out imaginary part of n complex number, so just use numpy.imag. As you know that a complex number have two parts, real part and imaginary part. So when you find out whenever you find out a real part, just write real function, and whenever you want to find out imaginary part, just write imag function, imaginary function. And third one is conjunction function, conj function, numpy.conjunction. It turns the complex conjugate. Actually, complex conjugate is nothing which actually it is obtained by changing the sign of the imaginary part. If the imaginary part is positive, then the conjugate number of that imaginary part contain negative sign. And last one is numpy.angle. It returns the angle of the complex argument. The function has the degree parameter. If true, the angle of the degree is returned, otherwise the angle is in radian. So these are some more functions. Actually, there are so many arithmetic functions used in NumPy array. Some of which are very important, as I described these in this video. So I hope you like this video. Thank you for watching this video.